In this video, we will create a rotary toolpath. A rotary toolpath is used on machines that allow simultaneous 4-axis movements to create a 4-axis surface machining toolpath, which cuts around or along the axis of rotation on the machine. In this case, we're using the x-axis. The rotary toolpath is a finish toolpath. To demonstrate both rotary cut and axial cut, we're going to finish the part using the rotary cutting method and then using the axial cutting method. Create a multi-axis toolpath. Select OK to accept the default NC name. In the classic view, choose the rotary type toolpath. Then select Tool. Click on Select Library Tool and find a 1-inch ball end mill. Then enter in a comment. Choose Cut Pattern. Click on the Select button here and choose this surface. Then click on the End Selection button up here. Enable Rotary Cut. With Rotary Cut, the tool travels around the circumference of the part. After each pass around the part, the tool moves along the axis of rotation for a subsequent pass. With Axial Cut, the tool travels parallel to the axis of rotation. After each pass parallel to the axis, the tool moves around the circumference for a subsequent pass. Ensure that the compensation direction is set to left. Change the stock to leave on surfaces to 0.005. Leave the cut tolerance set to 0.001. The cut tolerance determines the accuracy of the toolpath. Set the direction of closed contours to climb and the direction of open contours to one-way. Select Tool Axis Control. The Tool Axis Control settings determine the tool's orientation in relation to the geometry being cut. Rotary axis determines which axis is to act as the rotary axis in Mastercam. In this case, use the x-axis. Use Center Point allows you to generate tool vectors that terminate at the selected point. Deselect it to generate tool vectors that are normal to the surface. Axis dampening length determines the angular change between the vectors. Ensure this is set to 0.1. A longer axis dampening length creates less angular change between the vectors. A shorter length provides more tool positions and a tool path that adheres closely to the surface. Lead lag angle, either a positive or a negative value, tilts the tool forward or backward in the direction of the toolpath. Change this to 10. Minimum step controls the distance between passes. The distance is measured parallel to the axis of rotation. Change this to 0.1. Tool vector length controls the toolpath display by determining the length of the tool axis at each tool position. The recommended value is 1 inch. Select linking. Change the clearance value to 6. Change the retract value to 5. Change the feed plane to 1.5. And keep tool down within should be set to percentage of the tool diameter 300%. Then select the OK button to generate this toolpath. At this point, you should backplot and verify your part. But what I'm going to do is I'm going to hold down the right mouse click button, drag this copy after, and say copy after to create another toolpath. Select parameters. To be able to machine the other cam on this side, click on the select button here in cut pattern. Click on this surface to deselect it, and then click on this surface to select it, and click on the end selection button. Select the OK button to exit this toolpath, and then click on Regenerate All Dirty Operations. Then select all of the operations, backplot, and verify them. Once complete, your part should appear as shown.